So we all know the freemium models of like our favorite platforms like YouTube and everything. The problem with them is if it's free, then you're the product. And that is a big issue. Also, like we have that other problem of.
It's not showing what's on your screen. It's showing.
Yeah.
You have to mirror your display.
The other thing is like on platforms like YouTube, you cannot do illegal stuff. Like for example, educating people about Bitcoin and like telling them they should hold their own keys because you get banned. That's a bit of an issue. And that's why we need better platforms for file hosting, in particular also large files like videos. And that's why I created a protocol for people to sell files via Lightning. So file hosters can offer you, or like you can ask a file hoster for a particular file, for example, a large video, and then they sell that file to you and you pay via Lightning. And the essential thing here is that you don't want to trust the server. You don't want to have any trust relationship with the server such that everybody can become a server and you don't have to know them. The protocol should be such that nobody can cheat. It's the idea of an atomic swap of files against coins. So you get the file only if you pay, and the server gets the coins only if they give you the correct file. And the way we are doing it, like there is one version to do it, which is verifiable encryption, but verifiable encryption is a bit too slow. Like you could not have like 1 million clients or so, because it would be way too slow for the server. So what I implemented here is an optimistic protocol, and that means like it involves slashing. The server has to stake some coins in the liquid blockchain, and if they lie to you, you can slash them. And they stake like, let's say, I don't know, $100 or so, and they sell the file for you for $1. So they have a huge disincentive to lie to you because they will lose way more than they can gain. And here's a little demo. It won't be great usability, but I hope the protocol works. So first of all, somebody has to publish. Like we have basically 3 roles here. We have the author of the file, we have the server, and we have the client. And the author, let's imagine you just came up with a new protocol for cryptocurrency, and you wrote a nice white paper, and you want to publish that now. So you press enter, and this publish thing gives you the file ID. And the file ID is what you share with your clients, with the people who want to buy that file. And the file itself you give to the server, and then the server can sell it to people. And the people, they identify that file via that file ID. For example, you post that file ID to the cryptographer mailing list or whatever, like some kind. It's similar to BitTorrents. In BitTorrents, you have the same setting that the tracker is published somewhere, and once you have the tracker, you can download the file from untrusted sources. So we have the file ID now, and now you're asking the server, you're a client, and you're asking the server for that particular file, and then they encrypt it for you. And they have to encrypt it for every client, because otherwise clients could cheat and just decrypt it with a key that they used before. So then they encrypted it, and there are like a couple of outputs. The most important thing here is the payment hash, because... Oh, yeah, sure, that's a good idea. So the payment hash is how you identify that thing in the end. And the pre-image is what the server uses to create the invoice. I don't have a Lightning node. I had a Lightning node, but it didn't quite work. So now Super Testnet is my Lightning node. I give to him my pre-image, and then my super handsome server will create an invoice for me.
So you can't see my screen, but I'm creating an invoice using the piece of data he sent me, and I'm sending it back to him. So there it is.
So now we have an invoice here. And, actually we don't use the invoice yet, because the client first, before they pay, they don't want to pay before they have verified the file. So they verify first and say, yeah, this is the file ID that Satoshi sent to me on the mailing list, that's the same as here. This is what Satoshi sent to the mailing list, and this is what the server told me. Okay, very quickly. Now I've verified that, so what's missing now is that I have to pay the invoice. I'll pay the invoice quickly.
He's paying it with the Albi wallet. You can pay it with any Lightning wallet.
Yeah, this is compatible with any Lightning wallet. So I'm paying now, pay, now I've paid, and now I've bought that pre-image. Here's the pre-image. And now I can use that to decrypt the file. That's successfully decrypted. And now I can look in here, decrypted. Wow, great. Oh! Yeah, that's actually the thing. I think I ran out of time. The important thing here actually is what happens if it didn't work. If it didn't work, then I can derive a fraud proof from what the server sent to me, and then I can use that fraud proof, which is very compact. It's just like a Merkle path, and then I can send it to the liquid chain, and then I can slash the server using that fraud proof.
Just to confirm, all of this was done at TABconf, or what part did you work on it here?
I had that idea already before, but when I heard about this here, I wrapped it all up and tried to make it presentable and yeah.
Nice. Thanks.
Very cool.
Cool, so the judges are going to deliberate. We're going to announce the winners at the closing ceremony. I want to thank our judges again, Andre, Tidwell, Santos, and Brian. Also want to thank TABconf for allowing us to do this hackathon, and then Volker and CoinKite for our sponsors.